Alright, so now we're going to talk about doing some lattice work, and there's two steps involved with doing the lattice. The first step is you need to cut some grooves in the back of the bowl, or the platter, and whether you fill them or not is up to you, but you want to come up with some spacing on those, and then once that's done, you use the router to carve your grooves on the top. So that's again, this is one that was done without any filling on there. So what I'm going to do on this one is I'm just going to cut the grooves using a parting tool in the back of this bowl. One of the things I've learned is to start with a thicker rim, and then to leave you some room for tear out and some other things that some various roughness that could happen. If you do that, then you can turn those off and end up with a much smoother surface rather than starting with just a very small rim, a very narrow rim, and then if you do have tear out or lose a piece of the rim, it will be problematic. You won't have enough there to actually correct the mistake. So we'll go ahead and get this started here. We'll cut it with a parting tool. I've just laid out some rough lines in here. Again, this is just a practice piece, but I'll just go ahead and mark where I'm going to cut these grooves. I'm just going to cut two grooves in this one. So I'm going to go ahead and cut these grooves with a parting tool. I have a little handy depth gauge here that I'm going to cut a little bit more than halfway through on the bottom, and then I'll measure it with the depth gauge as we go along. I tend to work in metric when I do this type of layout. It's much easier to divide millimeters by than it is to do inches, but it's up to you how you do that. So, but I'll go ahead and get these cut now. Alright, let's work. We'll get this turned around, put in a chuck, and then we'll go ahead and get set up to do the lattice work on the front. Alright, so we did the work on the face and along the flutes along the cylinder, and now we're going to work on the radial cuts on the front, and in order to do that, the router needs to be able to rotate. So this is a combination of some materials I bought from Paul Howard, and I kind of put my own spin on it in order to make it work a little bit better. But essentially it's a linear bearing that the router is going to mount onto that allows the router to rotate along the face of the bowl. So, and because the system is somewhat modular, you can take the this base off So this is the base, and it as it comes with a plastic base that slides along, and then you just we're going to mount it onto the radial base. Alright, and as you can see with that now, what is allowed it to do is the router can now rotate through an arc on the face of the platter. Alright, so there's several design factors that you need to consider when setting this up. The router can be raised and lowered relative to the center line of the lathe, and also it can be moved on the table from this edge down in towards the middle of the lathe, and each one of those motions will give you a different arc on the radius of the router as it goes in through the rim of the bowl. So this is just a test piece I made with the router at different heights relative to the center line of the lathe, and also the distance in from the center of the lathe. And I just kind of look at this and use this as a guide. And what it allows me to do is, depending upon the radius of the bowl, I can look and make sure that my grooves are not going to intersect with each other as I and tear out as I get into it. So a couple of things that you need to consider when you do this is wood selection. Maple works, you want a closed grain wood in order to do this, because if you don't have a closed grain wood, you're going to get just too much tear out. So cherry also works well. Walnut would probably work, but this is a piece of poplar that was just a test piece that I was doing, and you can see that it just the wood just was a little too porous, and it just tore out as I was cutting the grooves on the front. So you need to be aware of that, and just choose your wood wisely as you do it. It cannot have any checks or defects. You don't want knots and those types of things in it as you do it, or you'll end up with problems like this. The other thing you want to consider is the frequency of the cuts and the size of the grooves in the back. So if you're going to keep an open lattice and not fill it, you need a little bit more structure in order to hold this together. So if you look at this bowl, really the only thing holding the rim on is this little bit of contact here, on the ends of these grooves here. So that's not very much. So in this one, the grooves on the back are not. There's more wood on the back to kind of hold this whole thing together, including more wood on the rim. If you look at the one that I filled with acrylic, where you have a lot more substance and body to it, there's very little wood on the back holding it together, and so it allowed me, because I cut the grooves in the back, I filled that with acrylic, and once that was set, I turned it smooth and then came around to the front, but now I had all that holding it together in the back, and allowed me to cut these grooves a little bit closer spaced as I did it. So you need to think about that if you're going to use that process, to go ahead and think about how much wood you have to leave to hold this all together. Also, the species of the wood would probably make a difference. You need to make sure your wood is very dry, because any movement at all will tend to, you now have all these weak points in the system, and if the wood tries to move, it's probably just going to crack off on your rim. Just a word of advice: if you are using Alumilite to fill all these grooves, you need to make sure that you oven dry this, because the Alumilite, a polyurethane resin, will foam with any kind of moisture in there. I put this in an oven when I cast the back, in order to dry it. And then after I did all the work in the front, I stuck it in the oven again for a few hours to get all the surface moisture on it. And again, to get the aluminite to cast properly. If you're using epoxy resins, they're not as moisture sensitive. You really don't need to worry about that. So those are some of the options you need to consider when you're putting this together from a design standpoint. All right, so I've set up the rotating jig on the base of the table here, and I just screw it down onto the wooden base. I did stick an extra clamp on here because, again, rigidity is so important when you do this. The other thing is you want to make sure that when you do this, that the bushing at the front of the jig is in contact with the front of your platter as you start, because again, that's another point for you just want to get rid of any motion or minimize any motion as you go along. So, but that's how it's going to go. It's just a matter of taking this in. I've drawn a line about 2 inches from the rim, which is about, I want to make sure I go at least that far, but typically there's no problem going past there. And you notice that I haven't turned out the bowl of this platter yet, because if you do get if you turned it out before you started, you're likely to get tear out when the router bit exits the cut. So I'm going to use the indexing on the lathe. Put 48 grooves on here, and we'll cut a bunch of them here in succession as we go along. You want to check and make sure you're intersecting your bottom grooves, and I notice that I am not on the, I'm hitting one of them but not the other one, so I'm going to increase my depth of cut a little bit. Move it back to my original cut here so I can recut that one. And I'm through both. I can see both grooves there as I went through. So I'll just advance it to the next Alright, so that completes cutting all the grooves. We'd like to talk a little bit just about selection of router bits for cutting these grooves before we break this down. So there's several choices in bits when you're just cutting a groove. The router bit I like to use is a spiral down cut bit, and I tend that this gives me a smoother cut and with a lot less tear out. The other choices are, you can use one with a round bottom. This is solid carbide and it's got 2 flues cut in it. What you want to avoid is a bit like this that has just one flue, just has one cutting edge, and you find that it's a little hard, probably hard to see on the camera, but if you look at the end, it's solid carbide, which you want, but it only has one cutting edge on it, which gives you a much coarser cut. When you get into the smaller diameters, you tend to get towards this, but if you can get one, even with a flat bottom that just has the 2 carbide edges on it, just 2 cutting edges on it, you will get a smoother cut. You realize that as you do this, you're cutting through different, you're cutting through end grain, you're cutting through side grain, and as you cut through this, and the bit's going to cut differently as you go through it. And there's going to be times where it wants to kind of self-feed through the wood, particularly when you go into the side grain. There's going to be times where you get on the end grain where you get more chips collection. You notice as I went through that at some points, I actually had to back off a little bit to clean some of the chips out of the groove in order to advance the bit forward. So just be aware of that as you go. So what we're going to do now is just going to take this down, and we'll go ahead and just turn. I'll just say a little bit of the turning of the middle here, how that works. And just from ease of handling, I like to take this off the table before I take the table off the lathe. Alright, some things to consider as you do this. Again, you got a lot of open surfaces here. You don't want to use a very aggressive tool to do this, and also make sure your tools are very sharp. I find that scrapers work as you get down to the finer cuts. Scrapers will work better. Also make sure that you undo your indexing so your lathe is free to turn as you go around. I just released the emergency kill switch on there, and I'm going to put my helmet on. You will find that it does turn better at a higher speed, again because of all the interrupted cuts on here, but it'll also, you could blow it apart if you're not careful, so just be careful as you do it and take light cuts. So again, we don't need to spend a whole lot of time turning this, but notice I did get some did chip out here a little bit. We'll finish that by just cutting that down a little further. That's it. We talked before about leaving enough surface, particularly on the top, in order to remove that. But find you can give it some profile. It gives it a good shape with the profile. But very fine cuts is what you need to do. If you start, these couple that I chipped here were my first cut that I went in. I felt it come off and I just came in a little too aggressive. So you just want to take it very gently as you come in. I'll show you the scraper here just as a final thing in there, just to show you how that works. Negative rake scraper. If you're going to use a scraper, make sure it's negative rake, and that'll work better. You can see that the scraper actually left a pretty fine cut on there, but again, you got a lot of edges there as you go through it, so just make sure it's very, very fine cuts as you go through. There's not a lot holding this edge on out here. You can actually just flex it with your hand, so you really have to take very, very fine cuts as you go through when you're doing that, and then you can just finish taking your bowl out of there and go forward with it however you want to do it. So if you wanted to do the acrylic on this, what you would start with, after you cut the grooves in the back, go ahead and fill those, let those set. Then you come back, cut your grooves in the front. Before you do any profiling, go ahead and just wrap masking tape around the circumference of the piece, just to act as a dam, and just fill the grooves with acrylic. They're going to fill the natural stops. The reason you don't cut the bowl before you start is it'll just keep it all in there. You don't have to worry about it flowing through the middle. And then do your profiling, and then you eliminate all the need for all these edges here that could chip out and cause you problems later on. But with careful cuts, you will get it to it will cut down, and you can make some pretty fine cuts on it. Again, just select your wood wisely as well. But sharp tools. As fast as you're comfortable turning it, you don't want it to fly apart on you, but that's how it's done. And I find that it comes out, if you do put a profile on these grooves on the lattice work, it does look much better. Alright, so this monster is something I made several years ago when I had a smaller lathe, but my desire was to be able to route some very precision and repeatable grooves in the faces of platters, and sometimes down into the bottom of platters as well. And I showed you this one in the beginning where it actually has some grooves cut, and these are stopped grooves, which this allows you to do. And it also has some smaller grooves within the larger grooves. And again, you need something very precise and very repeatable in order to do this. When I did this, I routed the larger grooves first, filled those with acrylic and metal, and then came back after those set. I refinished the surface and then came back a second time and cut the smaller grooves and filled those. So you need something, again, that's very precise, very repeatable, and it gives you very small, very fine control as you do it. And my solution to that at the time was to use a machinist cross vise. At the time that I made this, the cross vise actually sat down onto this base here, but when I got a larger lathe, I had to adapt it with these spacers. But essentially, it's a vise that it's meant for a milling machine, a machinist milling machine. It gives you motion in 2 axes by turning these. There are 1/1000th of an inch indicators on each one of these, so you know exactly where you are. I've adjusted it to get all the play out of it. It may be even a little tighter than you may want it, but it is very precise. It also can rotate on this table by loosening these nuts, and so if you're working on something that's on an angle, you can do that. And it also will slide back and forth along these T-tracks in order to give you adjustment depending upon where you want to be. If you're doing something down in the center of the bowl, or a wider bowl, if you're doing something wider, you can obviously move it outboard beyond the range of the cross vise. So this pieces here. This is a cross vise. This I purchased. The table I made. It's got, like I said, a rotating base, and this is a DeWalt trim router, which is, again, you don't need much of a router for this, but you do want something that is small enough to fit on your system here. And this one, and all I did is I made this piece here out of some scrap aluminum, and then mounted the router base right to this angle bracket that I made for it. And what's nice about this is once you get it adjusted, all the other, you don't have to adjust the router, all the other motion is done through these two knobs. Now you can see that what I did I created a series of stopped grooves on here. I've done 2 sets, and I just did this using the indexing on my lathe and my tool rest to draw these lines at whatever angle interval I wanted, and then I came in here and I drew the start and stop for each one of these grooves on there, and you've got to make sure you do it. Now you can actually, if you use the larger indexing wheel, you can do this by putting stops on the indexing wheel if you choose to, but I tend to just freehand this as I do it. But again, I put the start and stop points for each groove on here as I go, and I'll just go through. And the way I do this in order to get the same amount is I will adjust this so the router bit is just outside the surface of the wood, and I just count the number of turns each time that I do it in order to get the depth of cut. And so we'll go ahead and give that a shot. do the last inside one here. And again, I'm just eyeballing this. I would, if I was doing this for real, I would count the revolutions and make sure I was right on, but it's just a matter. Alright, so we're going to do now, this is just a small hollow form, just a practice piece, and just want to show some options for texturing the top and sides of this, and we're going to do it with two different methods. We'll do it once with the Paul Howard jig, which is set up with a, it's got the right angle bit in there, and with this, it's going to just follow the contour of the top and the side here, and then we'll cut a couple with that, and then we're going to stop, and I'll switch over and use the one with the cross vise on it, which actually gives you a little bit more flexibility because you don't follow the contour. You can do depth. You can adjust your depth and the angle of the cut just by using the angle that you put the cross vise on. So we're going to go ahead and get this started. And I noticed as I did my cut that my guide bushing loosened up. And we'll go ahead and get that set up. Alright, so what happened was the little set screw holding this bushing came loose. We found it and put it back in and tightened that in. And I also put a guide block on here, a stop, so each of the grooves that we cut on the starts at the same spot. So we'll go ahead and cut some more. Alright, so you can see this is just the pattern you're getting. By putting this guide block on and the stop, they all start at the same point here, and they all finish at, they all just come through the lip of it. But that's just an example of what you can do using this. I'm going to go ahead, leave the camera angle where it's at. I'm just going to get a couple on the side here, and then we'll show that, we'll just show those as we finish here. I need to take my guide block off. So what we have is we just cut some on the side. And we'll just show, just so you can kind of see the effect here. We cut them on the top and then on the side to come through. I don't know how well that's going to show up there, but just a pattern that you can do using the pole. So this is using the bushing and the guide, but you'll see that the challenge on this is if you wanted to vary the width of these grooves, you're kind of limited by the bushing just following it. So we're going to go ahead now and set up the cross vise, which will allow you to actually put tapered grooves in there, and we'll come back when that's set up. Alright, so now I have the cross feed system set up with a cove bit on there, and just simply to demonstrate that you can it's set up so that the bit will daylight up around the rim, and you get a lot more adjustment with, you can have it thicker at the bottom, thinner at the top, those types of things. It doesn't have to follow the contour of the piece. So that just gives you some options, and we'll just cut a couple of coves using this. And again, just another option that you can use. So again, just so you can see just a general pattern. So there is a little roughness in there. This bit's a little dull, so there's that graininess in there. It's just a little bit of jumping on the end grain there, but it could easily be sanded out. But that's just again an example of what you can do. A little bit more control of that with this. So just another option for doing it. So that concludes the demo. Just to recap, we demonstrated two different jigs that we use on the lathe to hold the router. One is commercially available by Paul Howard. The other is one that I built myself. They each do some different things. The Paul Howard is certainly more versatile. The cross-feed vise is more accurate and allows you to do some very refined work with it. We talked about the indexing systems, whether it's built into the lathe or whether it's an add-on that you're going to put on the lathe, and how essential that is. It's very important that whatever indexing system you use has to be provide a very secure attachment and not let the piece of work move while you're putting the router in it. The router does generate some torque, as you saw some from the examples, that what happens when it does move when it goes. We showed how to cut flutes into a cylinder, and this also could be done on a spindle, on a long spindle such as a chair leg or a baluster. We showed how you could cut grooves into the face of a bowl or a platter and fill those in with contrasting woods. With the cross-feed vise, you can do stopped grooves in the face of a platter or on the side if you choose. Again, something you can't do with a parting tool or some other kind of cutter on the lathe, because you don't have the ability to stop the grooves as you go along. And finally, we talked about lattice work on the lathe, where you can, and this is the piece that we started in the demo, and this is it finished after the bottom was completely turned. You notice I did put a profile on this surface. I was able to get the tear out that was in on the edges taken out by providing a little extra thickness as I went along, and but it's a fun piece to do, and it's one of those things where people say, how did you do that? Again, just as we talked about, going from this with these grooves down to this. Again, you can take a fairly boring piece of wood and embellish it and get some interesting effects. And finally, using some through cuts into a bowl, you can achieve this effect. Again, just a fun, interesting effect to go. And although you can't feel it, each one of these pieces are very, very light. There's not very much wood left in them, and which does present some challenges when they turn, because they do tend to flex as you go along, so you have to plan your work accordingly. So I hope you enjoyed this video. Feel free to leave me comments or ask questions, and have a good day.